This video is about analyzing motion graphs. So before we start analyzing motion graphs, we need to define two words, speed and rate. So speed is a change in distance compared to time. This is always going to be positive. It's always going to be positive numbers. Right? So the most common speed that we talk about is miles per hour, right? A rate then is a change in any unit compared to any unit. So a rate is going to be positive or negative. Right? Think about like filling a pool. It would be positive if we're putting the water into the pool. It would be negative if we're taking the water out of the pool or letting it drain. So a couple of words to talk about things then. If we have a skateboarder that is moving, how far the skateboarder travels from the motion detector is going to be his distance. How many seconds the skateboarder ride lasts is going to be his time. The skateboarder's rate describes a positive or negative change in his distance compared to time. So speed is a specific distance and time, but we also have rates that are distance and time when we talk about negative or positive rates. So in number 4, what are the results of the moving man beginning at -10 and traveling at a moderate speed away? So if we start at -10 down here and we move at a moderate speed, okay, it's a straight line because he's moving at the same speed or the same rate, but it's not very steep or flat. If he starts at -10 and he moves quickly away, our line is going to be a lot steeper. So it's going to be a straight line, but it's going to be steeper. What are the results if he starts at -10 and travels away from the tree for a second and then stops? So here he is at 10, he travels for a second where that line is, and then he stops. So when he stops, it's going to be a flat line. So he moves away for 1 second. So the line is going up. Then he stops. And the line is horizontal. So now let's look at a graph that's already done for us. So here, Terrence is skateboarding. The origin is 0, 0. This represents where the motion detector is placed. So if we look at this means he's 1 foot away from it. We want to describe. So in A, he's moving slowly, but it is a steady rate because it's a straight line. At B, he is stopped. And then at C, he is moving at a fast and steady rate. In number 8, using the graph, we want to match our descriptions. So at what point is he moving fast and at a constant rate? So fast and a constant rate would be C. He is stopped at B. He's moving slowly at a constant rate is A. and he moves fastest at C because it has the steepest line. The segment that he is stopped in is B because it's a horizontal line, and C is going to be steeper than A because it's going up faster. The segment rises in A and C, but it's flatter than segment C. So A rises but it's flatter than C. If we're looking for a steady fast rate, that's going to be C. A steady slow rate is going to be A, and no movement is B. So an uphill line meant the moving man was moving away from the tree and towards the house. What happens if we move him in the other direction, towards the tree? Then we're going to go as a downhill line. Because if the tree is up here, if the house is up here and the tree is here, when he moves, he's going down towards that. So at number 9, the moving man starts at 0 meters. He travels away from the tree at a fast rate. So if the tree is at -8, he's moving away from the tree, so we want to go towards positive numbers until he gets to 8 meters. And then he goes towards the house at a slow rate until he gets to the house. In number 10, the motion man starts at -5. He travels away from the tree for 3 seconds. So he's moving towards positive ground for 3 seconds. Then he stops for 5 seconds. 1, 2, 3, 4, 5. And then he goes as a quick rate back to the house. In number 11, what is happening in each segment? So in segment A, he is moving fast and away. At B, he is stopped. And at C, he is moving at a moderate speed towards. We don't want to say fast because he took, for A, he went a quicker distance in a shorter amount of time. Whereas C, it took him longer to cover the same distance. Where is he starting? So he's starting at this point. If this is 0, 1, 2, so he is starting at 0, 2, or 2 feet away. In number 13, the skateboarder was moving at 2 different speeds to create this graph. At which one is he moving a faster speed? So we want to look at which line is it going to be steeper. So in A, he covered more distance in a shorter time. So A is the faster one because it's a steeper line. In 14, when the skateboarder moves away from the detector, when is he moving away and when is he moving towards? So in A, if this is the detector at 0, he's getting closer to it in A. He is moving towards because the distance is getting smaller. In B, he's moving away because the distance is getting larger. In our last problem, using this graph, we want to describe what's happening. So from 0 to 2 seconds, they are moving slow and away. From 2 to 4 seconds, they're stopped because it's a horizontal line. From 4 to 6 seconds, they're moving fast away. From 0 to 6 seconds, it's flat again, so they are stopped. And then from 9 to 10 seconds, it is going towards, and it's a steep line, so this would be fast and towards.